All right, so hello everyone. Very good evening to everyone. So we'll be discussing the bi-weekly contest for 16th of March. All right. The time when I'm recording this video is 9:47 p.m. It's just the contest been over just now, so I solved the contest myself today. So I'll go through the problem solutions and the approach for it. Okay. So let's just quickly check. Okay. So the contest number for today is bi-weekly 126. We had four problems today. The usual marking scheme 3, 4, 5, 6. Okay. So a brief overview for the contest. The first two questions were very simple. Third questions was a bit difficult, and the last problem was, I would say, more on the difficult side because it was difficult to identify the DP as to how you would build that. Okay. So this is how the problem unfolds. Let's walk through the solutions. Okay. All right. So the first question, the simplest problem, let's just discuss this quickly. We have been given an integer array nums containing positive integers. We define a function encrypt such that encrypt of x replaces every digit in x with the largest digit in x. Okay. So it means that if we pass a number to the encrypt function, all the digits of that number will be replaced by the greatest digit of that number. So for example, 523 would become 555, 213 would become 333. Okay. Now we need to return the sum of all encrypted elements. So we need to encrypt all the elements and we need to return the final answer. Okay. So let's go through the discussion. Okay. Question one. All right. So if you just take a number, okay, let's say it's a four-digit number. A possible approach could be that you extract all these digits one by one, then take the greatest one, then build the number again. But that would involve a lot of code. So in order to solve this problem quickly, let's say this is our digit, this four digit is our digit. So I'll firstly convert it to string using the toString function of C++. I'm giving the C++ solution. Okay, the syntax, but this you can check the similar function for all the other coding languages. So that would also it would also work for those languages as well. This approach. Okay, so you firstly convert it to a string, then you check the maximum element. Okay, max element of this string. Okay, then you replace all with max element. Okay, and then you convert it back to a number. Okay. For this, you can use the stoi function, string to integer. Okay. String to integer, stoi. Okay. This function, you can pass that string, let's say this was str, and it will give you a number. Okay. So you have the final number and then you can just take the sum. Okay. So this was a pretty simple problem. The pro complexity for this was O of n and space complexity was O of 1. Okay. So let's go through the code for this question. The easiest problem perhaps. Initialize the answer variable. Okay. Extract each element, convert it to a string. Initialize the maximum character variable. Update the maximum integer variable. Okay. And then for the string, replace each character with the this maximum element we had here. Okay. And then we take the sum of the updated string by converting this back to integer first. Okay. So if you just run this, this will get accepted. Okay, I hope everyone would have solved this question. Let's move on to the next one. We have been given a zero index integer array nums of length n consisting of positive integers. We have been given a 2D array queries of size m, where queries of I is equals to index of I, comma k of I. Okay, so let's see what it means. Initially, all the elements are unmarked. Okay, you need to apply m queries on the array in order, where the ith query will do the following. Okay, so we need to apply the queries in the given order only. Mark the element at the index of I. Okay, so index of I means we need to mark the I indexed element, okay? And then mark k of I unmarked elements in the array with the smallest values, okay? So that means that firstly we'll mark the index of I, let's say the array is num, so we'll mark nums of index of I element. Then we'll look for the k smallest element and then we'll mark those, okay? All right, we need to return an answer of size m, where answer of I is the sum of unmarked elements in the array after the ith query. So after every query, we need to check the sum of the unmarked elements, and we need to return that. Okay, so this is what our question is. Okay, so yeah, let's go through the approach. Let me just go through my code again. I kind of forgot the approach I had used. Just give me a minute. Okay, someone take care. Okay. Okay, all right, simple. Okay, so let's move on to the next page. Okay, for this we have question 2. Okay, we have an array in nums. Okay, and we have some queries. Okay, what we need to do is we'll create a set here. Okay, we'll create a set data structure which will have a pair. Okay, pair data type of integer, comma integer. Okay, let's say s. In this, we'll push elements in the pairs of nums of I, comma I. That is the index and the element. We'll push this pair for all, like we'll run a for loop from I till n and we'll perform this operation. Okay. So this is the first thing. All right. Why are we doing this? Let's discuss that. Now, when I start processing the queries, okay. So I'll have to, let's say a particular query is the index I have to remove and the k value. So I'll have to check whether this index value is unmarked. Okay. How will I check that? I'll have to use a map for this because I cannot use a for loop because of the given constraints. Okay. So that would be a nested for loop and that is why I can't use it because if you see the constraints are 10 power 5. Okay. So you have to go for an n log n solution. So you'll check that if this index exists in your set or not. This can be done in log of n. That is why we are using set. Okay. If it exists, then you remove it and you update your answer variable, else you do not remove it. And after that, you will remove the k smallest elements from the set. Okay. One by one till the point the set is not empty. Okay. So till that time, you'll keep on removing the elements from the set till the time whether either k is greater than 0 or s is not empty. Okay, so either this two conditions. Okay, and you'll at the start you'll take an answer variable which will store sum of all elements. Okay, sum of all the elements of nums. Okay, so at every step whenever let's say you remove idx, so you will subtract this value from answer. Okay, because this element has been marked now, so you'll have to remove this element. Okay, so you remove it, and similarly you will repeat this operation for the elements that you are removing from the set here. Okay, and at the end of these two operations you will push this answer to your vector. Okay, so vector dot push answer. Okay, simple. All right, complexity for this would be n log n time complexity because you are iterating over the array and then you are performing the delete operations from the set, deletions or insertions. So that would be log of n. The space time complex, the space complexity would be O of n. All right, because you need to store all these elements in the set as well as are we using, yeah, the answer vector as well. So the complexity would be O of n, the space complexity. So yeah, this finishes the problem. Let's go through the code. Okay, this was a pretty, I would say, for this contest, I don't know, there's not much to explain in this. I don't know why, but yeah, let me know if you are unable to understand anything in the chat sections. But I'll be going over through these questions quickly because I don't see a lot of pointers I need to highlight in this contest. Okay, so that was the speciality of this contest from a mentor's perspective. So yeah, I firstly prepare my set, n variable, sum variable, insert the element, take it to the sum variable, add it to the sm variable, answer vector which will be returning here. Okay. Now you iterate over the queries. Okay. You check for the index. So q of 0 is the index of the element which we need to remove. So I'll check this pair in my set if it is present or not. If it is present, if it is not present, then to that means it is already marked. So we need not consider that case. But if it is not present, that means we need to mark it. So I'll look for that pair. I'll subtract the value of that element from the sum variable and I'll erase it from my set as well. Okay. Similarly for the next case, the k value. So this is remainder is my k rem. So I've represented this by m. I should have used k here. Okay. So while S is not empty and rem is greater than 0, I'll pick up the smallest element that is the beginning of the set. I'll remove it from the set and I'll subtract the value from the sum variable as well. Okay. That's it. And after both these operations, I push the updated SM value to my answer. So keep in mind this case, that could be a possibility that this value reaches 0 and we are still left with the query. So when you even try to process the queries, then it would come like iterator would be s dot end. That means you're not able to find it. And the size of set would be 0 already. So this case would also not work. So it'll straight away push the 0 value. Okay. So if you again run this, this would get accepted. Okay, so that finishes the second problem as well. Okay, I hope it was clear to everyone. Else, feel free to ask me in the chat section. Okay, so let's move on to the third question. We have been given a string s. S of I is either a lowercase English letter or question mark. Okay, for a string t having length m containing only lowercase letters, we define function cost of I for the index I as the number of characters equal to the ith element that appeared before it. Okay, so let's say if I have the string a. Okay, so cost of 0 would give me the value of 0, but cost of 1 would give me the value of 1 because the number of times a is occurring before this first index is 1. Okay, so the value would be 1, and for b the value would be again 0 because there are no occurrences of b before the current index. Okay, my task is to replace all occurrences of question mark in S with any lowercase letter I want so that the value of S is minimized. Okay, so I need to minimize the value of S. I need to return the total sum of cost for every index and I need to minimize that value. Okay, so yeah, and let's say if there are more than one strings possible with the smallest value, then I need to return the lexicographically smallest one. Lexicographically smallest would again be the alphabetically smallest one in the dictionary order. That is how you remember it. Okay. So yeah, let's go through the code. Sorry, let's go through the approach for this first. Okay. Now, a very important observation for this question was, which I also had foreseen for a long time. Again, for me as well, this has been a very long time since I have attempted a contest. So let me have some water. Yeah. So for question 3, the important observation was that, okay, if I'm taking, let's say this is my string, okay, some, okay, let's say at this position, at this position, at this position, okay, I need to place some characters, okay. So if you see, you can calculate the value this would contribute, okay. You can calculate that value. All right. Let's say if I replace it with A. Okay. So what I can see is that the number of occurrences of A after this thing, after this pointer and before this, if I can calculate that value. Okay. So that can help me. All right. And if you see if there are, let's say, 5 A's in my string at some point, this is the most important observation. So the answer is fixed for this. Okay. I know the answer for this would be 0 plus 1 plus 2 plus 3 plus 4. Okay. So if you generalize this to a formula, number of occurrences are 5. Okay. Answer is 4 plus 3 plus 2 plus 1 plus 0. So if there are 5 occurrences of a particular character, that would be the value that particular character will contribute to our final answer, final sum. Okay, so that is x into x minus 1 upon 2. Okay, this is what our answer is. Okay, so try to generalize it 5 into 4 by 2. So that would be 10. And if you sum this, that would also be 10. 4 plus 3 is 7 plus 2 plus 9 plus 1. That is 10. Okay. So this is the very important observation. So at any question mark, you need to just check what what is the character with the minimum frequency till now. Okay. You just calculate the frequency of all the characters at the beginning, okay, and then you come across a question mark and then check that which character has the minimum frequency till now, and you just place that character at the you'll take that character as a possible answer. Okay, keep that in mind. I'm not saying that if let's say I have a character C that has the minimum frequency, so this is sure that C would be placed here. Okay, I am just saying that C would be placed. कहाँ place होगा, I'm not specifying that. I'm not specifying the position yet. Okay. Why I'm saying that, we'll just discuss that shortly. Okay. So let's say if I've placed C somewhere, so I need to increase the frequency of C in my map now, right? Okay. Similarly, now I'll go to the next question mark. Now let's say if I come across A here, okay. Let's say A is the character which now has the minimum frequency now that I've updated the frequency of C. So the minimum character would be A. Okay. And let's say for this question mark, the character comes out to be B. Let's assume. ठीक है? But let's say if I fix it C, A, B, this is still not the best answer. This will give me the smallest value, but this string is not the lexicographically smallest. Okay. The smallest string would have been A, B, and C. Okay, so that is why I was saying that I'm not fixing the character here. I'm just deciding that I'm placing the character C at one of the question marks. Okay, that is why I was saying that, because we are still not onto the case wherein we have the lexicographically smallest one. That is also something we need to consider. So I now have the characters A, B, C which have to be placed. Now I can sort these. That would be again A, B, C only. So I'll place A at the first one, B at the second one, C at the third one. That is how we do it. Okay. So again, try to think about this pointer. This is the most important part of this question. This thing. Okay. This is the most important part of this question, this logic. Okay, this would help you generalize as to why I am just checking the frequencies. Students were doing, even I at the beginning thought about that maybe I should maintain a prefix and a suffix array and then I should do some stupid things. But that would be again very complex and not feasible, still not giving us the best answer. Okay. But yeah, so if you just generalize this pointer, that the answer would depend on the frequency of a character, not how they are what do you call as position. We need to only check the positions because of the lexicographically smallest character. For the minimum answer, we just need to check the frequency of the characters. Okay, so this is the very important pointer here. Okay, so complexity for this came out to be n log n because of storing in map and sorting and everything. Okay, and the space complexity would be O of n, where n would be length of string. Okay, do not just randomly write O of n. Every time keep in mind that what the variables in my complexity are. N, I am writing it here because I've taken it as the length of the string. If I take the length of string as x, so the complexity would become x log x. Okay, then you can't say that sir it is wrong. आपने तो n log n बताया था. I have also taken n as the length of string. So keep that in mind what n is. Okay. So now let's go through the code. Okay. All right, I prepare a map. ठीक है, I store the positions of the question mark. Okay, so if it is not a question mark, then I add it to my map. Else I push it to my question mark vector. Okay, I've prepared an answer vector here. We'll see why we are using this. Okay, this is to store the actual characters we'll be storing on question marks. Okay, so now I iterate over each question mark. I check what my minimum frequency is. I check which character holds that minimum frequency. I increment that character's frequency now and I push it to my answer vector and I break the loop. Because for one question mark, I have one answer. Okay, I don't know whether that is the only possible answer. It's like that I have five question marks. So for one of them, I fixed the answer to be a particular character. This is how we are moving. Okay, now when we come out of the loop, okay, I'll sort my answer. Okay, sort my answer because I said because we need to take the lexicographically smallest one. And now at each question mark, I'll place the answer at the ith index. Okay, so this would give me the lexicographically smallest string. So if you submit it, it'll get accepted, and the complexity would be n log n because you are adding some things to the map every time, and then you are doing the sorting operation as well. So the worst case complexity is n log n. Okay, now let's move on to the final question. The final question, you are given an integer array nums of length n and a positive integer k. The power of an array of integers is defined as the number of subsequences with their sum equal to k. Return the sum of power of all subsequences of nums. Okay. So we need to, they have given power of a array as the sum of the subsequences of that array that have a sum equal to k. Okay. Return the sum of power of all subsequences of nums. Okay, so we need to take all the subsequences of the given array, and for each subsequence as a separate array, we need to tell what its power is, and we need to take the sum of all those powers for all the subsequences. So if you see, this seems like a very difficult question at the first go, and it is a difficult one. But if you see the problem constraints, this can be very useful. N keep a value is very small. Okay, and because we are having subsequences, like it could be a possibility that I take a certain element or I do not take it. So there are two sub cases. You do not have an optimal greedy solution here. You have sub problems, what they say as. So whenever you have sub problems, you go for DP. Okay. So that is why we'll be taking a DP solution for this. Let's analyze how we do that. Okay. All right. Acha, also keep in mind that all the elements of the given array are greater than 0. So this will also help us at a later instant. Okay. Now let's say if I have an array of size n, okay, some n elements, okay. Out of this, if I take a certain subsequence of size x, which has a sum of k, okay. Let's say if I have take some subsequence, okay, and there are some elements, okay. So let's say these four elements sum up to k, okay. So how many subsequences would this particular how many answers would this particular subsequence contribute? Okay, think about this, because this is a certain subsequence, this is a single subsequence. It could be a possibility that this subsequence is a part of some other subsequent arrays. Okay, because we have been told that we need to take subsequences of the given array. So let's say I take this subsequence one, then I take something like this, then I take somewhere like this as well. Okay, so for all these elements, all these subsequences, it would contribute to the answer. Okay, now for how many subsequences it is contributing to the answer, that is the important part. Okay, if they are k elements, okay, I am pretty sure, sorry, if they are x elements, so I'm pretty sure that I'm taking these x elements in my answer. But for the rest of them, I am not sure whether I'll be taking them or not. So let's say how many elements are left, that would become n minus x. So I need to decide for these n minus x elements whether I'll take them or not. Okay. So if I take some element, I'll multiply 2, or I do not take it. 2 means either I take or I don't take. Okay. So this is 1, this is 2, and we'll go on till n minus x times. Okay. So the answer would become 2 raised to the power n minus x. Okay. This is the actual case. Okay. So if I'm taking a certain subsequence of size x, with the sum of k. So how many powers it will contribute to this particular subsequence? That will be 2 of 2 raised to the power n minus x. Because for the rest of the elements, you are not sure whether to take them or not. Okay, so you take the two case for each element, that you take it or you don't take it. It's simple. Think about it as a simple permutation combinations. Okay, so 2 into 2 into 2 for the elements which we are not taking or we are taking, like this 2, or somewhere in between 2, 2, 2 cases for this one, 2 into this till n minus x times. Okay, this is how we are going. So now this becomes very simple, that if you identify a certain subsequence with the sum k, you know that what is the answer that particular subsequence will give you. It will give you the answer 2 raised to the power n minus the size of that particular subsequence. Okay, Now let's visualize how we are building DP for this. Okay. So for a particular element, either you take it or you don't take it. ठीक है? And for the rest of the elements, you call the DP I plus 1. Okay. And you will maintain a count as well. Okay. So in this case would be DP and it will be I plus 1 and count plus 1. Okay. We are doing plus 1 because we have taken the element. Okay. So count is the actual size and also you need to maintain a sum as well here. So that would be sum plus x. X is the value of the element we have taken. And in this case, it would just be sum. Okay. So this would be the DP solution. These are the two possibilities for the DP. Either you take it or you don't take it. And at the end, what you do is you just return the sum of these two values. Okay. Just sum them and return it. Take plus don't take. This would be our final answer because we are visualizing this for the ith element. So if we are taking the ith element, what is the answer? If we do not take the ith element, what is the answer? And the base case would be that if at any instance some this sum variable we are maintaining this ignore, let me take a different pen. The sum variable which we are maintaining here, if this is equals to k, you return that 2 power n minus size is count here. So 2 power n minus count. Okay. This is the base case. Okay. And you need to memorize this uh, to have actual to optimize this further for the DP. So let's go through the code for this. Okay. Quickly. All right. So I just prepare my DP. The size is very small. So I've prepared a 3D DP here. Okay. Because in my DP function, I'm taking two variables, index I, the sum and the count. Okay, these are the three variables I am taking. So accordingly, I'll visual analyze this. Whoa, I'll take the size and the configuration for this array or vector, whatever it is. Okay, so resize it to 100, 110, 110 minus 1. Okay, minus 1 would mean we do not have a value till this point. Now let's call the DP function, the recursive function. So I've passed the nums k is the required sum I index. Okay, so for the ith index, either I take it. So if I take it, I'll add it to my sum as well. Oops, sorry. I add it to my sum as well and I'll increment my count as well. If I not take it, then I'll increment the I pointer either ways and but I won't be changing the sum and the count. And at the final, I'm just returning the sum of these two. Okay, I'm doing a modulus because they have added a this case that you need to return a modulo. Okay, the base case would be that if at any point if sum is equals to k, then I know what I need to return. So I just return that. Okay, another base case is if you reach the end of the array or if the sum is greater than k. This is where this case is helping us that the values are greater than 0. Because if you know that if at any point sum is greater than k, then you won't be able to reach k again because you do not have negative values. Okay, so you just take this case and you return 0. If it would have been the case that we had negative values as well, so we could have avoided this thing. Okay, we won't have added this thing. Okay, and also somewhere here we would have made some change. Okay, because negative value cannot be stored in a vector, so we would have to use some hashing, something like that. Okay, so yeah, this is another thing, and this is the memoization step that if I count sum is already present, then you return that value. I'm using the power function. I've made a power function to calculate power because the answer can be very large. So I've taken that splitwise, what do you call, I don't remember the technique name now. It's been a long time, but you just if you need to calculate power of a particular number, you divide it by 2, recursively calculate it. If it is odd, then multiply it by the number. Else, just multiply these operations, res into res modulus m. You can check. I think there's some name for this algorithm. I'm not getting it. If any one of you knows that algorithm name, you can comment it down in the chat section. That will be a homework from my side, and that would be a revision for me as well. Okay. So yeah, this is what we need to return, and that's it. That's it. That finishes the code, and that finishes the discussion for the contest today as well. So a general overview for the contests at the end, like we usually do, marking the questions. First and second one, I would say as 0 और चलो 1 दे देते हैं इसको 1 out of 5. This is again 1 to 2 out of 5. Third question is 3 out of 5, and the fourth question is somewhere between 4 to 5 out of 5 from my end. Okay, so this was a very difficult, not a very, I would say, difficult contest, because if you check, a lot of students have solved all the questions. Okay, so yeah, it was not a very difficult contest from that perspective. Okay, so I hope everyone would have done well, and feel free to shoot up your questions in the chat section. And I'm repeating it again and again. Please share these videos with your friends and family, whosoever needs it, because the more people I have here, the stronger the community grows, and more such videos will be coming up. Okay, at the moment it's like I do not have a lot of engagement, and therefore we end up missing videos on some weekends and all. Okay, so try to increase the engagement here. Okay, try to share it with your friends and whosoever needs it. Okay, until that time, happy learning. Have a great weekend tomorrow. Okay, bye bye everyone.